Welcome to Summarize Science, where we break down the latest breakthroughs in technology for everyone. Today, we are looking at a fascinating new AI framework called TokenGS. Creating 3D models from 2D images is a major goal for artificial intelligence, but it has historically been very difficult. Most existing methods are pixel-aligned, meaning the AI tries to guess the depth for every single pixel in a photograph. This creates a massive problem. If you use a high-resolution camera, the computer gets overwhelmed by millions of unnecessary data points. TokenGS solves this by decoupling the 3D prediction from the actual pixels of the input images. Instead of following the path of every pixel, the model uses what the researchers call learnable tokens. These tokens act like smart placeholders that can move around and figure out the best place to represent the 3D scene. By using an encoder-decoder architecture, the model can control exactly how many 3D points it needs, regardless of the photo's resolution. This makes the entire process much more efficient and allows for faster reconstruction times. One of the most interesting parts of this paper is how it handles noisy camera data. Usually, if a camera position is slightly off, the 3D model looks blurry or distorted. TokenGS is much more robust because its 3D points aren't strictly glued to the original camera rays. The system also introduces something called a visibility loss to keep 3D points from floating in places they shouldn't be. This ensures that the generated model only puts points in areas that actually help build a clear picture. Another huge leap forward is how this system handles moving objects, which is often called dynamic reconstruction. The researchers developed a way to track the flow of a scene over time, allowing for smooth video-like 3D replays. In the comparisons provided, older models often create spiky artifacts that look like jagged needles sticking out of objects. TokenGS produces much cleaner geometry, making surfaces look smooth and realistic. It also allows for test time scaling, which is basically a way to let the AI think longer to get even better results for a specific scene. This tuning process happens without degrading the general knowledge the AI already learned during its training. The results shown on various datasets prove that this method outperforms many of the current state-of-the-art systems. For the average person, this could eventually mean high-quality 3D scanning is built right into our mobile phones. Imagine being able to walk through a room once and instantly having a perfect 3D digital twin to share. To recap, TokenGS makes 3D modeling more efficient by moving away from pixel-by-pixel calculations. It handles moving scenes and messy camera data better than almost anything that came before it. In the future, this approach could change how we archive memories, design games, or even perform remote surgeries. By separating the detail from the resolution, the researchers have opened a new door for computer vision. It demonstrates that the key to better AI isn't always more data, but smarter ways of organizing that data. Thank you for tuning in to Summarize Science for this look into the future of 3D technology.